Hello everyone. My name is Adil Mansoori and I am working in Econstruct as a trainee structural design engineer. So today I am going to share my journey with Econstruct. So since my college days, I want to become a structural engineer. So I am getting in touch with Econstruct through YouTube itself. So after a BTech, if you want to join like a core placement like a structural engineer, then there is a problem to get. It's a very hard to get like a structural job in core field in core civil engineering. Only you will get like jobs after us as a site engineer job role after a BTech. You will you will get. Then it's very hard to crack the core placement. So if you want to become like a structural engineer, then you must have some practical knowledge and along with knowledge of practical things of projects, and you must know the software, various softwares like if I'm talking about for designing a project from start till end, you must know like etaps, safe, SAP 2000, Procon, RCDC, and AutoCAD. So let me brief you the functioning of these software. So for ETAPS, we do generally we can do like analysis and design of superstructure with various types of analysis, and with SAFE you can do foundation engineering. Basically, it's a flat plate analysis and design software. In SAP 2000, you can model and analysis and design like solid elements, structures like you can model in SAP 2000. It will ease you like retaining walls, dams, culverts, chimneys, etc. These are the structures you can handle with SAP 2000. In Procon, you can do element design. For individual element, you can design and refer for your projects. With RCDC, you can this is add-on software. It will help you to detailing work. And AutoCAD is drafting and drawing work. It's mandatory for all civil engineers to learn that software. So here I have completed 6 months with Econstruct, and today I am now capable to design G+30 RCC building and steel structures. Recently, we had finished one group project, steel structures, that is bungee jumping. It is situated in Goa. So if you want to become a structural engineer, then Econstruct is the platform to achieve your dream goals. So here Econstruct is providing like master study in structural engineering. So for that course, you must have strong fundamentals and fundamentals in civil engineering. Basically, many iterations you will do in structural engineering, and without patience, one cannot be a good structural engineer. So let me introduce one project in front of you. Let us see. So this is my group project. My group members are like me, Adil Mansoori, and other one is Lijin Marugis and Ganesh Jela. This project is basically approved and checked by our founder, respected Sandeep sir, our joint managing director, respected Shraddha ma'am, and founder and MD of Econstruct Design Build Private Limited, Mr. Sandeep sir. Talk about the contents of these projects: introduction, general project information, standard codes, material and section properties, schematic approach of analysis and design, drawing and mathematical model, loads, lateral loads, analysis, stability checks, design of structural elements, foundation design. So basically, our ultimate aim of this project of designing and analysis, like the structure should durable and serviceable during the lifespan of this project, and also it should be economical, and it should be pleasing in appearance, and it's the aesthetics of the project should be good. So this is the basically main of a design engineer. And one thing is like we have considered the Indian standard codes for this project, and many international codes practiced wherever it is required. So talk about the project information. The name of this project is Bungee Jumping Goa. Its location is Goa. We have used in this project like a grade of concrete is 250. Type of steel structure is like steel structure. Floor to floor height we have considered 4.2 meter for typical stories and 3.8 meter for bungee platform area, and over the terrace 3.2. Length of the structure is maximum at the bungee level platform 34 meter, and the rest other, as you can see, a briefing area we have considered is like 16 meter. Width of the structure is like 6 meter, and number of stories in this project is like 13 stories. So under the guidance of codes, we have used like for steel structure, we have used IS 800 2007. For dead load, IS 875 part 1. For like live load, we have considered IS 875 part 2. For wind load, IS 875 2015 part 3. For various structural sections, SP6 part 1 we have considered. So talking about material sections, we have like used, as I said, steel we have used Fe250 grade. Its weight per unit volume is like this. A modulus of velocity is this, and the Poisson's ratio is 0.3. Coefficient of thermal expansion is this, and the shear modulus is like 80769. So here we have talk about the section properties. For column, we have used like box section and the I beam for the cantilever portions wherever it is required. So here we have used the maximum column size is like 350 cross 300, 12 mm thickness at the outer periphery of the project. And here we have used for beams for cantilever portion, we have used like non-prismatic beam of linearly varying thickness like 24 meter and 6 meter it is for the briefing area. And we have used various types of sections. For slab, we have considered checkered plate 6 mm thickness, and for the bracings we have used box sections. As you can see here, the various types of box sections are there. Yeah, this is the schematic approach of our project. First, we have done modeling, apply load analysis, and design. These are the architectural plan. This is the ground floor plan. This is the briefing level, and this is the bungee platform level. This is the structural framing plan of a bungee platform level. Wherever are denoted various types of different types of beams, columns with different markings, and here is the bracings. As you can see, this is the exploded view of this structural framing plan. And now the schedule for the structural framing. This I have used like B1 ISHB 150, B2 for ISLB 175, B3 is like ISLB 100, and B4 and B5 is like we have used non-prismatic beams. Columns are there, and bracing is like ISB 72 cross 74.8 thickness, ISB Indian Standard box 132 cross 132 cross 5.4 mm thickness. So this is like a mathematical model. We have model in ETAPS. So this is a very different typical floor plan. This is the briefing area, and this is the platform area, bungee platform area. And this one we have provided like fixed supports to the structure. This is the 3D model of 3D mathematical model of bungee jumping. Here we have provided releases to the bracings. This is the section view of like non-prismatic beam. Its length is 24 meter and it is linearly varying. It is box section for column for beam. And this is also non-prismatic beam. Length is 6 meter and it is linearly varying. This section is I section. So different types of loads are there: gravity loads and lateral loads. In gravity loads, like we have considered dead and live, and the lateral loads, wind and earthquake is there. These are the shell loads. As you can see, we have considered dead load for general rooms 0.5, for live is 3, platform 0.5, live 2, staircase 1.5 for dead, and 3 for live, 1 terrace for 0.5 dead, 0.75 for live load. Terrace is only for service purpose. There is no other things in steel structures over the terrace. So LMR we have taken 10. here is the calculation of lift load calculation. So we are getting 9.73 as you can see in this calculation. So we have rounded up to 10. So this is the frame loads. We have considered in this project insulated wall. Its basically thickness is like 100 mm and the floor to floor height is like 4.2 and the density of wall is like 10 kilonewton per meter cube we have considered. So for wall load we are getting like 4.2 kilonewton per meter load. For insulation wall 4.2 kilonewton dead load and railings we have considered 1 kilonewton as per the IS 875. Wind loads calculation we have done as per IS 875 part 3 2015. So class of the structure is important. We have considered this building and design life we have considered for this building is 100 years. Basic wind speed is like 39. It is in zone 2. So Goa is in zone 5. Sorry, zone 5. Risk coefficient we have considered table number 1.06, clause 6.3.1. Terrain category is 2. Terrain category K2 factor is 1.18. Upwind slope is less than 3. Topography factor 1.06. Importance factor we have considered 1.3. Now this is the important phase here. Basically in this structure the wind force is majorly governing because lightweight the steel structure weight is light, dead load weight is light as compared to RCC. So in this project earthquake force is not governing, wind force is majorly governing. The major challenge in this project we have faced to control it's a big cantilever portion and also a lateral displacement due to wind forces. So for this project we have considered importance factor like 1.3 as per the code. Basically it is situated in Goa and it is coming in the coastal region under 200 kilometer region of a periphery and it is nearby coastal. So we have considered 1.3. So if we consider 1.3 means 30% we have to give more importance in terms of base shear. So if we go with one only, we are getting wind base shear is like 30% less. So for this we have to consider the more tonnage. So next we have calculated like height of the structure is 53.2 and length is like 6.2 and width is like 6.5 and width is like 6 meter. So here we are getting as per the external pressure coefficient clause number 7.3.1 the windward coefficient up to briefing level we are getting 0.95 and leeward is like 1.25 and up to bungee platform we are getting like 0.85 and 0.75 because of these calculations H by W and L by W we have get the pressure coefficients from this clause number of IS 875 part 3. Here are the various types of analysis. As you can see, static, dynamic, linear is wind, non-linear is geometric, P delta we have considered in this project, dynamic effects, linear model, walking vibration we have considered in this project. So this is the P delta analysis. We have considered dead load scale factor is 1.5. Majorly governing it is there 1.5 times dead load. So we have considered that dead load is 1.5 times. This is about the wind analysis I have explained earlier. So in this project, basically we have not gone through the diaphragm of the application of wind. We have not gone through diaphragm. We have considered the cladding and we have provided the wind pressure coefficients through windward and leeward directions. As you can see here, wind pressure coefficient Wi in the global y direction and it is in the global x direction. So here talk about the base shear. As I earlier told you, like importance factor, if we considered 1, then we are getting this base shear is like 700 and Wi. This base shear is we are getting like 1000 kilonewton. So here after providing 1.3, then 30 times 30% it will increase. So here I am getting these types of base shear due to wind forces. Yes, talk about model analysis. According to IS 1893 2016, clause number 7.7.5.2, table number 7. So first three modes, your participation should be more than some UX, some UI, it should be more than 65%. Here my first mode in X direction, and the fundamental time period between these three modes, it should be like 10%. So my first mode is like purely in translation in X direction, and second mode is purely translation in Y direction, and my third mode is like rotation. So here RZ value rotation for first mode is like 0, so it is okay. And the nth mode, your model participation should be more than 90%. Next, we have like walking vibration we have performed in this project. So talking about the internal parameters, so average weight of person we have considered. So basically it's a huge cantilever is there, 24-meter cantilever is there. So we have to perform vibrations over the platform. It should be stable while it should be in service condition. So we have considered the average weight of person 75, and we have multiplied the factor of safety. We have taken like 2. Walking vibrations 2 cycle per second. Forward speed we have considered like 600 per second. Impact duration of impact 0.5 seconds. And the rhythmic activities, we have considered acceleration threshold like rhythmic activities and foot bridges. So it is 5%. And we have provided these coordinates of foot steps. Here we have mentioned. So in one direction we have considered at the platform from left to right, and another direction we have considered from right to left. So this is the result of walking vibration. So as you can see, my DC ratio, it should be less than 1. Here it is safe in walking vibration. So acceleration should be less than the demand versus capacity should be always less than 1 for walking vibration analysis. Here I am getting less than, hence it is safe. So talk about the stability checks of this model. Here the deflection. So I already told you like it is a 24-meter cantilever is there. So here my allowable deflection is as per the IS 800 2007. Its span is like 2400 and divided by 250. I am getting limit is like 100 So deflection, if I am talking about, I am getting UZ deflection here at the last portion of the cantilever. Maximum it is 41. I am and subtracting with this the axial shortening of my column. So I am getting 36.97. Which is less than 100. My allowable is 100 and I am getting 36.9. So hence it is safe in deflection criteria. So as I earlier told you that displacement wind forces is governing in this project. So my lateral allowable displacement for of the structure height is like 53.2 meters. So divided by 500, I am getting the allowable displacement is like 106. And here I am getting less than that due to WX direction and WY. So hence it is safe in the wind displacements. Now talk about the structural element design. So here these are the load combinations. As you can see, we have considered from IS 800 2007 from table number 4. These are the design preferences. I have taken code like as I earlier told, IS 800 2007. Framing type we have considered a special moment resisting frame. Impedance factor is like 1. Seismic zone is like 3. Considered P delta, yes. And all the factor of safety we have considered for 1.1 and 1.25. Here these are the by default values of the deflection limits and the all other things as per the preference of IS 800. These are the by default software values. So design overrides are there. Framing type SMF. Section class we have considered class 3. Semi-compact. Buckling class we have considered A for this project. So my structure is passing in design. All frames are passed with the stress and capacity check. So value engineering is important as per the economical point of view. So these are all my section that I have used, and it's the weight. So total weight I am getting like 221 metric ton after the value engineering. Initially I am getting 261 metric ton of steel. Then I do the iterations and reduce it to 221 without compromising the safety and durability of the structure. So now foundation design. The project is situated at Goa. So SBC of soil, it is nearby the river bank. So SBC is like 100 mm. So we have opted for this project like pile foundation. So grade of concrete I have considered M35. Grade of steel Fe 550 we have considered. And pile details, talking about pile details, 8.5 meter pile. Pile diameter is 400. Pile capacity is like 950. And 6.5 meter 300 pile diameter, and 316 is the capacity, 310 is the capacity of pile. So here I am getting the base reactions. It is basically this data is coming from the ETEPs. So base reactions for dead plus live is very less. Here after the iteration I came to know like the base reactions for wind forces is governing, and the base reactions is quite more in wind forces. So I have considered that in my design of pile foundations. So these are the arrangements of pile. These are basically, this is the safe model. This is the pile cap, and I take the thickness of pile cap in this pile foundation design 750 mm. These are the stiffs of the columns, and these are the point springs wherever the arrangement of piles I have given. Here in the 4 columns I have provided less capacity pile because the requirement is less. The point reactions is quite less here. So I have provided less diameter pile, and outer peripheral the requirement is like quite more. So I have provided like 400 mm dia piles over there, the arrangements. So this is the point spring that I have provided in safe. So as you can see, the capacity, the allowable deflection limit for the piles is like 5 mm. So I have divided my capacity by 5 mm. That's why I am getting 192 point springs, and here 62. I have performed the pile design in like Procon. So these are the inputs of this pile in Procon, and this is the output of this. These are the soil profile I have considered for this project. The different pile data is there. This is the capacity of other pile and the ground profile. As you can see, very dense and soft clay, very soft rock, and soft rock we have considered up to 15 meters like this. The lot combinations for this we have considered IS 800 2007, this clause and this table, as you can see. So this is my pile point reactions forces I am getting with the strength envelope. Basically, it is the maximum I have considered, and here I am getting like less point reactions as per my pile capacity. So it should be less than your pile capacity. So it is, I am getting like less than 950 everywhere. So it is safe in reactions. Talking about settlement check, I have considered dead plus live load is equals to 1 combinations, and I am getting settlement is maximum settlement is like 1. So it is safe. Then the allowable settlement for pile foundation is like 5 mm. Now talk about the punching shears. For the point spring for the pile, I have provided the point spring, and I am getting the punching DC ratio is less than 1. So if it is more than 1, then it is not okay. It should be revised, and it should be less than 1. So here I am getting everywhere is less than 1. For the stiff column, the punching DC ratio is not showing. So I have calculated manually for that stiffs. So here is the punching shear check with strength combination, maximum stress at bottom face, and I am getting like in S13 direction 1.18 value. In S13 direction, minimum combinations I take strength envelope, and I am getting 1.26. Here 1.19 is getting S23 minimum combinations strength envelope. Here is the S23 maximum envelope. Maximum I am getting 1.3. So talking about my allowable calculations, the allowable punching shear is like as per the IS 456. Tau c is equals to 0.05 root FCK into KS. Here KS is what? KS is like 0.5 plus beta c, where beta c is like what? Beta c is equals to shorter dimension by longer dimension of column. So KS, in any case, KS cannot be more than 1 for LSM limit state method. So beta c is like 300 and 350. I am getting 0.85 with the sum of 0.5. I am getting KS value is 1.35. So it cannot be more than 1. So KS I have considered is like 1 and FCK is 35. So I am getting tau c value allowable punching shear is like 1.47, and previously in previous slides I am getting for column like it is less than 1.47. So my punching check is okay. It is passing in punching. This is the crack width calculations that I have considered for this project for the pile cap. So as per IS 456-2000, the crack width should be less than 0.2 mm, and here I am getting the crack width is like 0.06. So it is passing in crack width criteria. So this is the requirement for pile cap reinforcement. We have done finite element method of designing of slab. So I have considered like 300 mm meshing size. Here the requirement of direction 1 bottom rebar. This is the requirement for direction 1 top bar. This is the requirement for direction 2 bottom bar. This is the requirement for direction 2 top bar. So I have provided like a sketch of reinforcement. So I have provided 16 at the rate 125 for direction 1 bottom bar. It is satisfying my reinforcement criteria. So it is okay with this reinforcement. So I have provided next direction 1 top bar AST is like 16 at the rate 125. So it is satisfying this criteria for this pile cap. In direction 2, this is the direction 2 bottom bar at 16 at the rate 125. It is passing. Yes. In direction 2, this much reinforcements I am getting 16 at the rate 125 I have provided. So this is the reinforcement details of this project. That's all for this project. Thank you very much.